This is the last example for section 4.6, and it's a problem involving two trucks. Truck A travels east at 40 miles an hour. Truck B travels north at 30 miles an hour. So we're going to have an east traveling truck and a north traveling truck. And it says how fast is the distance between the trucks changing 6 minutes later. So 6 minutes later is 6 out of 60 minutes. That's 1/10 of an hour. And I say that because these units are in hours right here. So in order to set up where they are 6 minutes into their trip, we need to find out how far they've traveled after 6 minutes. So the truck that's going 40 miles per hour times 1/10 of an hour is going to be 4 miles away. And truck B, so this represents 4 miles away, 4 miles east of where we started. Truck B, traveling at 30 miles an hour for that same 1/10 of an hour, is going to be 3 miles north. So after 6 minutes, truck B is up here at 3 miles north of the starting point. Truck A is here at 4 miles east of the starting point. The starting point's right here. And the question, how fast is the distance between the trucks changing? If the two trucks are here and here, then the distance between the truck is that, which happens to be the hypotenuse of this triangle. And as this truck continues to move north, and as this truck continues to move east, this hypotenuse is going to continue to get longer. And so we're being asked for the rate of the change of that hypotenuse. So we're going to go ahead and find out what that hypotenuse is at exactly 6 minutes. So you might notice this is a 3, 4, 5 triangle. So that hypotenuse should be 5 miles. Now let's go ahead and look at our rates. So looking at the Pythagorean theorem, x squared plus y squared equals z squared, differentiating that with respect to time, if you notice, if you kind of go through here, as these trucks drive, x is changing, and y is changing, and z is changing. So all three of these quantities are changing, which means all three of these will have an implicit form of the derivative. So all of the x, y, and z are changing. There is nothing that is staying constant. So let's go ahead and differentiate this. So differentiating x squared gives us 2x dx dt. Differentiating y squared gives us 2y dy dt. And differentiating z squared gives us 2z dz dt. We can simplify that by getting rid of the 2's if we want to. And so we have this relationship then that the x position times the x rate plus the y position times the y rate equals the z position times the z rate. So the rate of truck A is at 40 miles per hour. So I'm going to label that on the drawing. Truck B, their rate is 30 miles per hour, so I'm going to put that on the drawing. And we're being asked to find the rate of change of this distance on the hypotenuse between the trucks. So this gives us all our information we need to put into the expression here. Our x then is going to be 4 times our dx dt, 40. Our y is 3, our dy dt is 30, and our z is 5. So calculating this out then, 4 times 40 is 160, 3 times 30 is 90, so this whole thing is 250. So we have 250 equals 5 dz dt divided by 5, and our dz dt, which is the distance between the rate of the distance between the trucks changing, is going to be 50 miles per hour. So just to kind of look at our essential question again, how can the derivatives be used to evaluate rates? Derivatives are instantaneous rates, and we're going to need to use implicit differentiation to find the answers to these related rates questions. At this point, you should be able to do both the homework assignments day 1 and day 2 for the homework for related rates.